Okay, moving on, let's put some filters into our oscillator, into our 3D synth. And so this is what we have. So this is what we have so far, and we're actually gonna, it's a nice thing to have these, be able to, you know, to, and, you know, and now we have loads of harmonic content that we can actually filter. So let's go ahead and move into our voice there. Again, we're working from the ground, building this thing from the ground up. First we implement some signal processing, then we come back and do the interface. Okay, already you see that we have tons of, you know, U menus and dials and a gain control here, and this is gonna grow quite significantly to the point that there will be a point in which we're going to be dealing only with these user interface elements. But we're going to postpone that as much as we can. For now, we need to implement the signal processing. So let's move on. This is going to be a quick one. So let's go ahead and open our original voice object and implement some filtering here. And so what I'm going to build here on the side is again something that I'm going to encapsulate later. So I'll start with just creating a dummy inlet and a dummy outlet. So then I can build something here in between, encapsulate and get rid of these dummies. And our filter is going to have two parameters, three actually: the type of the filter, the cutoff frequency, and a resonance. So let's create three receive boxes: one with the filter type, and the second one with the cutoff frequency. So receive, cutoff, and receive. Resonance. Okay, and we're going to use a state variable filter that gives us four types: low pass, high pass, band pass, and band reject, or band pass, or peaking and notch filters, as some people call them. So let's go ahead and create this object. It's called FV for state variable filter, and it's going to take cutoff frequency as one of the arguments, and then resonance as the second of the arguments, and it's going to output all four types of filter. Which one do we want? Well, we need a selector object to choose. We're likely not going to want them all at the same time, and now selector needs an argument for how many do we do, which one do we want to turn on at any given time. So we have four options. So this is going to be our low pass, our high pass, our band pass, and our band reject. And then the filter type is going to inform selector of which filter we actually do want. Okay, and so this is a pretty simple thing to do. Obviously, Max in other languages might not be that easy. And now this guy here is going to take a signal as it's going to take a signal and filter it and produce an output there. So we're going to actually select the middle here and encapsulate it as filter. And we should be looking good. You see inside of this, we receive a signal, filter it, and output it. Okay, and nice. So now we can get rid of the dummy inlet and outlet, and go ahead and filter these friends here. So we're going to take these three guys here and send them to the filter, and multiply the output of the filter by the envelope. And that's going to be all for now. And I mean, if we have time, we should probably do some filter envelope in this video. Let's see, or perhaps in a new one. So let's delete this and undo it to reinstantiate this whole thing. So it's we probably need to. Oh, by the way, we need to create the parameters. So let's go ahead and create a new U menu here. And this time, this is going to contain. So this is going to contain low pass, high pass, band pass, and band reject. Okay, and we also need a +1 there because we don't ever we need a filter, right? We don't. I mean, actually, we do not, because we can have this. We can turn off the filter, and that might be a good idea. So let's introduce this off element here. So now this is going to goes 0 for off, 1 for low pass, etc., etc. So we're going to send this to our waveform 3, but we're going to send this to filter. Right? Remember, we had a receive filter on the other side of things here. So filter, and we had a receive filter. That's where we're sending. Okay, and also we're going to need 2 more sends, one for the cutoff. So send cutoff, and another send for the resonance. Okay, and let's go ahead and create 2 more dials. Actually, I'm going to copy these things. So the resonance dial, I'm going to just copy from here, and this is already formatted. And this will go between 0 and 1. However, the cutoff, this is a frequency, so here we need to scale this a little differently. We also need a flow output, but the minimum value now, the maximum value, say it's going to be close to Nyquist, so 20,000, and the minimum value, something that is meaningful, like 12 hertz. So we don't need anything less than that. Actually, you don't ever want 0 here, and otherwise the filter may blow up. And okay, circular, yeah, seems pretty good. Let's see if we didn't make any mistakes. And so we start with some, say, rectangle here, and some gain there, and okay, work. Perhaps this is not. Oh, okay. Perhaps this was. Okay, so this is something that perhaps we don't. We need to do something different if we want to turn this off. So let's go ahead and we can do this later. So let's just remove the E off for now. Otherwise, it's not going to output anything when it's on off here. And let's give the +1 there. Cool. Okay, back. Okay, so let's put this this guy away down there, a sawtooth, and then the triangle, and so maybe some pink noise. Then this is meaningless now, but now we can go ahead and low pass. Oops. You see, because of this noise, we have a lot of high frequency content. So we probably want to ramp these parameters later on. For now, we should be fine. Let me put back maybe another sawtooth there and back tone. Okay, so in the next chapter here, we're gonna actually introduce an envelope to this filter so that we get some sweeps as we play notes. And then there's a lot to do still. Okay, see you later.